Welcome to part C of the Model Sim Full Adder tutorial. Last time when we left, we had finished inputting, writing up the test bench and closed the file, so we have the full adder and the full adder test bench here. We are now ready to go ahead and compile the design. So let's go ahead and open up the project window again. There are a couple of ways we can do it, but let's just do the following. Right? Let's go ahead and see here. We have the sources here, so pick the full adder. You can see what the status is right here. Okay, the question mark says, hey, I don't know what the status of the file is. Okay, let's go ahead and right click, click compile, compile selected. What happens? Well, if you're lucky and you did not make any syntax errors or so on and so forth, you'll say compile of full adder was successful. Wonderful. Okay, let's go ahead and take the test bench. Right click, compile, compile selected. Voila. Okay, does this happen often? It never does, right? It rarely does. Okay, this is an artificial example. Everybody makes typos and mistakes and coding errors and so on and so forth. What has actually happened here? Let's go back to our file browser and go back to our directory and just take a look here as to where we're at here. What has happened? Well, the project file is still there. There's the full adder VHDL and the full adder test bench in our transcript file. But if you look into work, something new has happened. Okay? What has happened is that when we compiled, we actually generated these files. You shouldn't touch these files. You don't need to look at these files, but it's there so that you understand what's going on here. Alright? So let me close that out. Okay. What do we need to do next here is that what we've done is we've essentially ran it through what they call the analysis stage. What we want to do next is to go ahead and generate the simulation. Alright, so let's go to simulate. Now in the version of Model Sim that we have in the lab, that's the full version. I have the starter edition. This is also the same edition that you guys will have if you download it, or the student edition as such. So what you want to do is click on Start Simulation. Okay. So where's my design? Remember when we created the project, we had a library, and the library was called Work. The default library for all designs in VHDL is called Work. So if we take a look here and pull down under Work, you should see here your two entities here, full adder and full adder test bench. Okay, and there's the architecture for both of them. Okay, what you want to do is, what is the top level in your design? Well, the top level in this design is the test bench. The test bench instantiated the full adder. So go ahead and select that. Okay. Alright. Let's take a look at some of the other tabs here before we click OK. Click on the VHDL. Alright. There's a few options for VHDL, none of which we need to go ahead and turn on as such. Alright. If you're using Verilog, there are more options for there. Do you need to add any libraries? We're not adding anything. There are no standard delay formats here, and we're not doing any profiling or doing other things as such. Okay, so the default should be fine. So let's go back to design. We have selected full adder TB. So look at how the design unit is picked. It's work dot full adder underscore TB. The dot is a hierarchy specifier, just like the slash is for directories and so on and so forth, or backslash. Right? So let's go ahead. Alright, so what do you want your resolution to be? We'll just leave it in the default here. We'll figure out what that is in a second, and click OK. Okay. Oh, that's just wonderful, and you're wondering where did your design go to or whatever. Okay. Model Sim has a dot file or where it saves the preferences. Okay, I use Model Sim quite a bit, so it's from whatever I had set up. So I have this wave window. Let's go back and just dock it back. All right, let's see, and I have that here. And let's go ahead and minimize that thing back here, right? And then we get our window back. All right, what do we see here? What we have is, first of all, we're in the simulation mode. Okay, all right. Over here, we have our design. We see that the top level is full adder TB. The full adder test bench had an instance called U0. What was our instance U0? Well, that was our full adder. If I go ahead and max zoom it out, okay, and you can see U0 is our full adder, and so on and so forth. Okay, and then within that, each one of the processes are going to be given as such. So you got line 11 and line 12. Oh gosh, what are they talking about? Let's go and take a look. Full adder, line 11 is right here, the assignment, and line 12 is this assignment. Makes sense. Okay, let's go back to our sim window. All right, what is line 25 here? Well, that's in full adder TB. So let's see, line 25. Well, that is the beginning of my process. Okay, everybody is ready to go, and it wants to start executing at this point. So let's go back to our simulation. All right, let me go ahead and minimize this window back. Okay, so that is my sim window, right? I still have access to my project. I still have access to my library. You can add more tabs that you want. So let's take a look here. At the full adder TB, we have the following objects in the design, right? We have A test bench, B test bench, and so on and so forth, okay? At U0, we have A, B, carry in, sum, and C out. Does it make sense? It tells you the direction of these and so on. What we're going to do is we're going to create what they call a waveform window, all right? Look, before the days of graphics, you just used to see numbers printed out, and you just essentially drew out the picture in your mind or on a piece of paper. Okay, those days are long gone. All right. So what we're going to do is this. Here's my full adder test bed. Let me right click, okay, and go to add to a wave. I'm going to just literally take all the items in this design. Okay. If the design is large, you don't want to do this. Here, what do we have? 6 and 6, 12 signals. No, excuse me, 5 and 5, 10 signals. No big deal. Okay. So that same operation shows up in this transcript window right here. Let me maximize that for you. That shows up as add wave recursively slash from the top level, give me everything. Now we can do a few things here. We could either control the simulation through a command line window, or you can use the point and click. Okay, the point and click, use whatever works for you as best. Let's go ahead and see how we can do this. I am a command line guy. Okay, so let's see. We have the project. Let me bring him back here. Minimize that. Okay, we're back to here. Let's take a look right here as to what we have here, right? So what this is telling me here, remember I just type and go real fast here. Let's see, environment back, how long you want to run, continue run all, break. So let's just go ahead and change this here. Let's see, 90 picoseconds. Let's just set this thing to here. Why not? Let's just set it to 30 nanoseconds. Okay. All right, and then click on run. Ooh, and things happen, so on and so forth. Right. Question is, where is my waveform window? All right, let's see. window. Let us see, where did my waveform go? Watch. Let's see, not the data flow, not the watch, full adder. Da, da, da. Where did my waveform window go? This window, view, wave. Okay. Well, if it's lost, you know how to get it back. View, turn it off, turn it back, and there's my waveform. Alright, let's go ahead and maximize him. Alright, and what do we see here? Oh, no wave. And you can zoom out to zoom full here. Why there are no signals here? View. Alright, what happened here is we did not start this thing correctly. No big deal. Let's go ahead and just simply to stop the simulation, right? There's two ways we can do it. Let's just go back and stop it and start it again. Simulate, end simulation, end it again. Alright, let's start again. Simulate, start simulation, work, full adder test bench, okay. Let's go ahead and go to right click, add to wave window, all items in design. There's my wave window, there are all the items in here. 30 nanoseconds is set, let's go ahead and run. Okay, let's maximize the window here. You can zoom in, minus, so on and so forth. Let's go ahead and zoom full. What do we see here? So we have our signals that we're looking at. We're looking at A, B, and C in at the test bench level, and some at the test bench level as such. You can zoom in and zoom out of these this area. You can see right here at time 0. Now, probably not good to work in the picoseconds because we're running everything in nanoseconds, but you can change that later. So we see that after 10 nanoseconds, okay, the first input changes here, right? Let's click right here. We're at 0, 0, 0. Okay, it was, well, it just did it by alphabetical order. We did it as C, N, A, and B. Okay, so well, let's rearrange that. Okay, by simply taking carry in and just putting it right up there. Okay, so it's in the same order. You can go ahead and see that. So 0, 0, 0, 10 nanoseconds, 0, 0, 1, and 20 nanoseconds, 0, 1, 0, and so on and so forth. So we've run it for 30 nanoseconds and so on. All right. Does this make sense so far? Well, it should have been what? 0, 0, 0 should have given us 0 sum and a 0 carry out. That's correct. Okay. A 0, 0, 1 should have given you a 1 sum and a 0 carry out. A 0, 1, 0 should have given you 1 sum and a 0 carry out, so on and so forth. Now these signals are of course the same as these as such, but just shown at the level of the full adder itself, okay, in the hierarchy. Alright, let's continue the simulation, right? Let's see here, run. Let's see, run, continue, run. Let's run it for another 30 nanoseconds. Okay, voila. Okay, run for another 30 nanoseconds. Okay, and another 30 nanoseconds. Okay, well, but what happened? Well, you can't see the whole screen yet, okay? Alright, let's see, zoom out full. Wonderful. Run all, run continue, run 30 nanoseconds. Let's see, 0, 1, okay. Okay, wrong button. Okay, so now let's take a look at the whole. And you can see right here, roughly we had 8 combinations, 10 nanoseconds each, so we were pretty much done by 80 nanoseconds. So we went through 001, 000, 001, 010, 011, 100, 101, 110, and 111. Okay, and you can verify that indeed the sum and the carryout are behaving as expected. Okay, so this is your waveform window as such. All right, let's see what we can do with this thing here. All right, you have this waveform window. You can do all kinds of nice little things on here. Is one of the nice things is you can print to a PostScript file, which is really nice. So let's go ahead and do that. Okay, I'll just dump it to a file. Okay, wave call PS, and click OK. You can of course run it on Windows. The command will be different. You can go ahead and print out the waveform as such. All right, and go ahead and click OK. All right, so let's go and see what is what. Okay, documents. This is why it's kind of nice to know where you're at. Projects, ladder doc, video. And there's wave.ps. And of course, it's going to print it upside down and show me in this fashion. All right. Obviously, you can take a look at that. Let's see here. Rotate right. Okay, and now we want to rotate left, right, rotate left. No, rotate right twice. Rotate right, rotate right. Okay, not exactly what I'd wanted to see. Okay, and there you go. A simple waveform picture, so you can include this into your documentation and so on and so forth as such, or you can just do a screen capture and that works also. Alright, okay, let's go back. So what have we done so far? We've taken a design, created a project, entered the design, created the test bench, compiled the design, simulated it with a little bit of difficulty, okay, and verified that the functionality is correct. Okay, this is the basics of what we're going to do in this class. Thank you very much. Have a good day.